Well, here we have it. We have the body of the violin. In the tray we call that the corpus. We have the strings as it comes. We have the pegs needing to be fine fitted. At the moment they're probably sticking, making clicking noises, and difficult to tune. It's also come from another country to this country where the humidity is different, and so things have changed, and so we need to check those pegs. We need to check the top nut here, the grooves. We have a bridge to put on, check that it fits and put the correct curve. We need to check the camber, which is a camber this way, a dip in the middle of the fingerboard, and we have a camber this way, and both those cambers have to be correct for the violin to play well, and so they have to be checked as part of our setup. We also have a chin rest, and this may well be loose. In this case it's not, and we may have to adjust it, but it equally might be too tight due to these humidity changes, and we would therefore have to do some work. And we have a button at the bottom here, and the string will be stretched from this area, and we'll use a tailpiece, and that will have to be fitted to the violin here. In this particular case we make sure that it's of good quality and that the threads work well, and that it is going to finish in the correct position in relation to the bridge. Inside the violin we have a little piece of wood here which was called the soul of the instrument, and that is the sound post, and we need to check that for its correct position, and we use a gauge similar to this which we place inside, and we're able to tell the actual position of that sound post, and in this particular case it's over here, which is a little bit towards the centre of the instrument and would want moving and refitting, and that would be something else which we have to do. So we would then we would look at the balance of the bow and just check that it's not, for a young player, too head heavy or too hand heavy, and that would be natural. As we're setting up we would get the feel of the bow. The most important thing we would check would be that when we tighten up the hair, this part called the frog isn't going to move too far back and cause problems in the internal mechanism here, which I'll explain later. Usually we'd recommend a gap of about a pencil in the middle here to a young player who wants to know roughly how to tighten up, and then we would just tighten it to that, and we would look down the bow, and what we're looking for here is, when I can hold it still, we would be looking for the bow stick being reasonably straight. It depends on the quality of the outfit. As bows get more expensive, more as they go over the £100 mark, then it is critical that they're absolutely straight, and that the hair and the stick are in alignment and look straight. And this bow, it's okay. I'm going to look now at one of the most important elements of the violin setup. Okay, with this violin we're now going to check the bridge position, and we take a measurement here, which is one of the very important measurements of how well a violin is going to work, and we just check that it's within the normal parameters that we would expect. So we are actually measuring the distance from the body of the violin to the top nut, and we then measure the bridge position in the same way, and those two have to be a certain measurement in order to be correct for the intonation of the violin and the stopping of the strings. Having our position correct, we would then check the bridge for fitting, and we would put some powdered chalk, and we'll be able to look at the places where the chalk is touching, and then we take a very sharp blade and we can see where it's been touching and where it hasn't, and we remove some timber, some wood, and we do a careful fitting and back to the violin, and we keep doing that until we get a perfect fit.
Okay.
With the factory instrument, there will be a curve on the top of the bridge, and there will be a thickness. We will correct all of those to thicknesses which we know make the bridge lighter and make it work better, and we will place the bridge on the violin, and we will extend the fingerboard up to the bridge and mark it. We'll then mark it on the bass side, and then we'll put the correct measurement of height for that string and the correct measurement of height for this string, and that will depend on the brand of string being fitted to the violin. Metal strings will want one setting, a little lower. Dominant strings will be a setting in the middle, and gut strings will require a higher setting so that the strings don't vibrate against the fingerboard. Post, and we've done some refitting. We use a powdered chalk on each end, and we put the soundpost in the violin, and we will put it in and take it out several times, marking carefully where wood needs to be removed to make it fit correctly. The tool we use is called a soundpost setter, and we just pop the soundpost inside the violin like that, and we pull it towards us and just tilt the violin so that the soundpost will stay in the position that we've put it very lightly. We can then use our soundpost setter to put the violin soundpost in its correct place, and it has an end which is eminently suitable for the job to pull it, push it, and we must make sure that we don't put the soundpost in too tight. If we have this part of the violin, the top of the sound hole, higher than the table of the violin here, that is an indication that the soundpost is pushing the table up and it's too tight. If it's too slack, we would get this part of the violin going down and that part of the table being higher, and those are things during the setup. All that sort of fine detail is in the repairer's scheme of things, all in the brain, all waiting to make sure that the violin plays as well as possible. The method that we use is a simple one to check where that soundpost is sitting. We will put this cut piece of card inside, and it will show us exactly where the soundpost is sitting at the moment, and we've readjusted this to be in the correct position this way. It's a little bit too far forward, and so we will move it with our soundpost setter gently back, and until we get it in the position that we know it works best. We normally look for something about half a bridge foot behind the bridge. And so we look inside with a mirror and a light, and we can look all around in different places, and we can find exactly how the top and bottom are fitting. What we don't know is how upright the soundpost is at this stage, and so we remove the button from the bottom that is the string holder. We take that out, and then by looking inside and shining a light, we can look and see that the soundpost is either vertical or not. And so with all of those checks, top and bottom, looking through, we then can move the soundpost in relation to the bridge when we do our tonal adjustment next. Now, in the case of this particular violin, when we attempted to take this out, it was very tight, and that again is probably due to the humidity differences in the country that this was made to the country it's now come to, and it was too tight, and we cannot push it in enough for it to fit properly. So we have two choices. We can shave a little off using a peg shaver, or we can use a reamer in the hole, depending on why this is too tight. And in this particular case, it's just a little too tight at the top here, and we can just remove a small amount of wood with the reamer and then refit, and it will be a perfect fit. We then have applied the curve to the top of the bridge to a template which we use for all our violins, and this template, the curve, is based on the curve of the fingerboard, and so the two will then have the same curve, but the E string on the violin will be lower and nearer the fingerboard, something like 3.5 millimeters from the fingerboard, and the G will be higher from the fingerboard when we put the bridge on the violin, and that will measure something like 5 or 5.5, or maybe down to 4.5 sometimes. It depends on the strings. And so our bridge is there. We have checked the heights, and our next step will be to put the strings on the violin, having worked on the pegs. Here with the pegs, we have moved on a stage and we have now refitted them. I explained briefly that from the factory to here there's some movement of the wood which had caused the peg holes, or the peg, whichever, to be not round enough but actually oval in shape, and so we've had to use a combination of our cutter and a reamer to achieve a good fit with these two nice shiny rings showing that we have a good fit. And we then use a proprietary peg paste and we apply that to those two parts, and then the peg now is perfectly round, and it's a little bit further into the hole than it was, and so it's a bit better fit all round. Finally, the pegs are fitting beautifully and they have a good grip, and so the strings will stay in place when you're tuning them, and you won't have problems with them slipping. Our next step is to fit two strings. We're going to fit the E string at the top of the violin. We're going to make sure that this part of the top nut is correctly shaped, and we're going to put a little soap in the groove, and then we are attaching the string to the peg. It's important not to have pieces of the string passing through the peg hole and sticking out the other side, because as you turn the peg, the piece sticking out will touch parts of the scroll and it will make a buzzing noise which will be very, very irritating to the player. So we put the E string on with enough tension to hold it in place. We're now going to put the bottom string, or G string, on, a quality string of higher quality than the string supplied by the factory. And here we have to adjust so that that string isn't sticking out the other side, and we're going to go once around there, once over the string, and then wind the rest of the string to the very edge of the peg box. We make sure that we have some soap. It's possible to use soap. It's also quite possible to use a pencil and put some graphite into these grooves if you haven't got soap. Either are very efficient and stop the string from wearing and make it a smoother ride over the top nut here. And we want to think of that as a pulley. We're putting the string over something which is going to take it neatly into the peg box. So our next stage is to put a little soap in the grooves, and you'll note that on the bridge we have a little vellum which is attached and glued, and it protects the wood from the very thin E string biting into the wood, and we fit that to all our bridges. So we upright the bridge there, and now we can take this protective cloth out carefully. Just wipe away any excess soap. And this now means that we can measure the string heights, and there are several ways of doing this. If we're using a ruler, we can just put the rule onto the fingerboard and we check, and we have 3.5, and we can check there and we have 5 millimeters. We're just going to tighten them, put some tension on. Not up to pitch yet, and recheck the measurement. Correct. Correct. So finally we have the strings, and we are able to start to put a rough tuning into the instrument. As we do that, we have to make sure that the bridge is just moved and settled back where it belongs, because the strings are pulling it forward, and we have to make sure that we pull it back so it doesn't collapse forward with a mighty bang. We'll fine-tune the instrument and play it with a bow later as part of our test, just to make sure everything is correct. We can finally do a little check where we can just rotate the violin like this and check that the curve of the bridge is indeed correct, and that the D and the A strings are equally spaced above the other strings for not catching with the bow the strings that are too low. So we have a nice curve. We can check by visually that the G is about the right height and the E is about the right height. Finally, we've released these tuning knobs so that we can then just tighten them down after we've tuned the violin on the pegs, and we tighten these down till we feel them taking up. And the reason for doing that is that we don't want them to allow the adjusters to touch and foul the front of the violin. So by having these tuners set where they are, everything is correct, and the player can now, a young player who's not experienced, will find it easier to tune on these, and the usual routine, the teacher will adjust the pegs on a month-by-month basis, and check the bridge so that the young player can just use these, because they may not have enough strength in their wrist to handle pegs, and that's where fitting one of these Wittner tailpieces is very important. And finally, we want to check that this tailpiece is in the correct position in relation to the bridge, and we have a measurement of between 53 and 55 millimeters for this, and we just check that and make sure then the strings are now at their correct tension. If this was a short measurement, the strings will be too high tension, it will affect tone. If this is too long a measurement, it will be the other way, and we'll have a sad, sort of rather quieter sound that we don't want.
Fantastic.
Our violin is now ready.
Yay!